easy.
Go ahead and explain the difference to me.
Okay,
And
so
give,
a dependent.
and give an example of each.
Okay, so a dependent variable is a variable that depends on something else. And then independent or dependent events is when an event depends on something else.
Give me an example of independent events.
Independent events would be like taking a card out from a deck and then putting it back and then grabbing another one.
Good. Or flipping a coin twice.
Uh-huh.
They're independent of one another. The odds on the second flip are going to be exactly the same as the odds on the first flip.
Exactly.
Give me an example of dependent events.
A dependent event would be like you take out a card and you leave it out and then take another one.
Yeah. Or how about the probability that it's going to rain today and the probability that it's going to rain tomorrow? They're dependent on one another because they're not completely independent. In other words, the weather runs in days. You know, if it's raining out right now, well, the odds that it's going to be raining tomorrow are better.
Yeah.
They're not completely independent of whether it's raining today or not.
Right.
So, but the card example is probably a better one. It's clear there. Okay. So number 2, if event A is drawing a queen from a deck of cards and event B is drawing a
king, I think, yeah.
Are events A and B dependent or independent?
This would be independent.
Yeah.
Well, it doesn't say, yeah, they're putting it back, so.
Well, they're actually two different. In other words, one event is the odds of drawing a queen from a 52 card deck, and the other event is the odds of drawing a king from a 52 card deck. So yeah, in essence, they are replacing it, but it's they're totally independent of one another as long as they're each being drawn from 52 card decks.
Okay.
Okay, number 3. Rolling a 2 on a 6-sided die, which is 1 out of 6. And event B is rolling a 4 on a different 6-sided die. Those dependent or independent?
Event B is rolling a 4. This would be dependent.
Nope, independent.
Still independent.
Same as the previous question, really. In other words, the previous question was really 2 different decks of cards. You got a 52 card deck here, and then I got another 52 card deck. Well, the odds of getting a queen out of the first deck do not affect the odds of getting a king out of the second deck. Same thing with 2 different dies. The odds of rolling a 2 on the die I have on the left is this independent of the odds of rolling a 4 on this other die that I have on the right. And they're both 1 out of 6, but they don't depend on one another.
Right. That makes sense.
So, find the indicated probabilities. When events are independent, so I can write.
Okay. Would you just do P of 0.3 plus P of 0.9?
Well, yes. In other words, only if they're independent can you do that. Okay. But it's the probability of A plus the probability of B.
Okay.
If they're dependent, then it's the probability of A plus the probability of B minus probability of A and B. Hold on. Okay. I need to pull out my book here.
Yeah, no problem.
As much as I love probability, and I've dealt with it my entire life, when it comes to tutoring math, For some reason, probability, my brain just will not memorize these things.
Oh,
So I gotta look, make sure yeah, it's a weird thing. You would think that probability would be my best subject. If you knew anything about my life at all, it would definitely be my best subject.
oh, no worries.
We're wrong here. It's not the probability of the sum, it's multiplied.
Oh, okay. Times them, okay.
And an example would be, what is the probability of drawing a queen from one deck and a king from the other deck? Well, it's not going to be very high, right?
Right.
Because the probability of drawing a queen is 1 over 13, or 4 over 52,
Uh-huh.
times, if I added it, notice that I would get 2 over 13.
Right.
Well, it's not going to be bigger. In other words, the odds of getting a queen out of one deck and a king out of the other is going to be much smaller than the odds of just getting a queen out of one deck.
Yeah, for
So
sure.
if I made the mistake and put a plus sign here, I would quickly realize it. In other words,
Because it's
the
above
best
1.
answer is 1 over 169.
Yeah.
Whereas if I added them, it would be 2 over 13.
Oh,
So this answer makes much more sense, and that's why this is multiplication. Okay.
okay.
So we'll be able to do all of these. Now before we go to dependent,
Uh-huh.
so what's number 4 going to be equal to?
So 4 would be equal to 0.27.
Good. 5. Now
It's
5 you
it's evens.
well you have to take their answer 0.06
Uh-huh.
and make that equal to the probability of A times 0.3.
Okay.
Now you can solve for the probability of A. In other words, once you set up the equation, it doesn't matter whether your variable is on there or there or there. As long as
Right.
you only have one variable, you can solve for it, always.
Okay.
Okay, and how do I solve for probability A?
So you divide by 0.3.
Okay, now what is that equal to?
0.2. So 20%.
Yeah,
Cool.
that's exactly right. Mm-hmm.
Cool.
Now, I'm not sure how you did that in your head. How did you do it?
So I did 0.06. So like I just ignore the decimal, just did 6 divided by 3, which
Okay.
is 2, and then just put the decimal in front.
Okay. In other words, the way I did it is 0.6 divided by 0.3 is clearly 2.
Yeah.
So if my numerator is smaller, then my answer is going to be a factor of 10 less than 2, which is 0.2. So
Right.
that's the way I do it in my head. It doesn't
Okay.
really matter. As long as you can come up with the right answer, you can do it. Number 6 is pretty much the same. I think we can bypass it and go to number 7.
Okay, so yeah, you would just do
Just set up an equation and solve for the missing, which is probability of B.
okay.
Okay, I can't read this number. What's that number on 6?
I believe it's 0.25.
Okay, so what's the rest of it? 0.25 equals what?
P of A, or P parentheses A times 0.75.
No, it's P of B times 0.75.
Or P of B, yeah, my
Or
mistake.
0.75 times P of B.
Okay.
So P of B is 0.25 divided by 0.75, which is 1/3.
Yeah,
33, 0.333.
cool.
That's what that's going to equal. Okay, now we'll do the harder one, which is
Okay.
dependent event.
Yeah, let's do number 8. We just have to do the evens.
Okay. Now, dependent events have a different equation.
Okay.
The probability of A and B not going to be the same equation as the other because these events are dependent. So it's the probability of A times the probability of B, like before,
And then
times,
minus, right?
excuse me, I didn't write that correctly.
Oh, it's okay.
It's the probability of A times the probability of A given B has already happened.
Okay.
In other words, that's the way you write it, with a line between the A and the B.
Gotcha.
And
Okay.
yeah, okay. In other words, this is conditional probability.
Yeah.
And so they're going to give us, for number 8, they're going to give us the probability of B bar A. Ooh. I wrote it wrong. It's not A given B, it's B given A.
Oh, okay.
It's probability of B given that A has already happened.
Oh, gotcha.
Okay.
Okay.
In other words, the probability that it's going to rain tomorrow, given that it's raining today, is different than the probability that it'll rain tomorrow knowing nothing about today.
Okay.
Okay? Actually, you don't even have to know what any of this means. You just have to memorize that formula because
Okay.
every one of these questions is going to give you 2 out of the 3.
Right.
Okay? So if we look at A, 8 rather, then I can say that the probability of A and B is 0.25, so I can fill that in for that.
Okay.
Probability of A is what I'm solving for. Still there? I heard a little beep.
I am. That was weird. Yeah, I heard that too.
Okay. Times 0.5. In other words, the probability of B given A is,
Okay.
make sure that I'm stating that correctly.
Okay.
Yeah, that's exactly what it means. It's the probability of B given that A has already occurred.
Gotcha.
That's what's 0.5. Okay. Now,
Okay.
solve that for P of A. What do you get?
0.5.
Okay.
Cool.
And 10, right?
Yeah.
Find the probability that the first friend chooses a biography, the second friend chooses a classic, and the third friend chooses a historical novel. Okay. What is the probability that the first friend chooses a biography?
So let's see. Biographies 10, classics, and 5. Okay. So 18 altogether.
Okay. First of all, let's do this.
Okay.
That's what they're asking, right? Probability
Right.
of all 3 events happening.
Yeah.
Well, that's the probability of A times the probability of B times the probability of C. These are not dependent.
Right.
Okay, so what's my probability of A, which I'm going to call that the first friend chooses a biography. How
Yes.
many biographies are there? And there's 18 total books?
Yeah, so 3 over 18.
Yeah, well, 1/6.
Uh-huh.
What's the probability of the second choosing a classic?
And that would be 10 out of 18?
which is
Or
the same
2 out of 9?
as 5/9.
5/9, yeah.
And then the probability of the third friend choosing a historical novel.
5 out of 18.
I can't simplify that. So that's equal to whatever it's equal to. 25 over some big number.
Okay, yeah.
And that
That's
may or may not be simplifiable. Let's see. Can I simplify anything here? I don't. No. If I in other words, I get 25 over 6 times 9 times 18. There are no factors of 25 that also divide into any of these three numbers.
Mm-mm.
So I just have to use either manually multiply that together to come up with that.
Okay.
Okay. You don't have to do 11.
No.
Okay.
Just the evens.
12.
Yeah. So you're playing a game that involves spinning the wheel shown. Find the probability of spinning the given colors.
Okay. Now, what they don't tell you that they should is that
Uh-huh.
these angles are all equal.
Oh, okay.
Because if they weren't equal, we wouldn't be able to solve the problem.
No.
Not without them telling us what the angles were. But
Uh-huh.
knowing they're all equal, how many different colors do we have?
Let's
Not
see.
colors. Let's say how many different sectors do we have?
16.
How'd you get that so fast?
I just I
One,
just counted
two,
it before.
three, four blues.
Uh-huh.
There are 5 yellows. There are 4 greens. And there's 3 browns.
Uh-huh.
I missed some?
Um,
That is 16, yeah. How'd you count them so quick? Because, oh, you just counted them starting with any one and then going around to the other. Okay.
yeah, exactly.
So we have to assume that the angle, the central angle of each sector
Uh-huh.
is the same. In other words, it's whatever 360 divided by 16 is.
Okay.
Not that that's important to know that angle, it isn't. But it's very important to know that each of those angles are the same
Uh-huh.
because that determines the probability of what color comes up when I spin
Right.
it. Let's see. There were 4, I guess there were 3 reds.
Uh-huh.
There were 5 yellows, 4 blues, 4 greens.
So would you just do 3 plus 4? So it'd be 7 over 16
Well,
for 12?
find the probability if you're going to spin 2 times that it would be red the first time, blue the second.
Uh-huh.
So what that means is the probability of red and blue with 2 spins.
Right.
Precisely red and then blue. Well, what's the probability of red?
3 out of 16.
What's the probability of blue?
4 out of 16.
And what do I do with those two?
Just add them together, right?
Multiply.
I multiply them together. Okay.
Both things have to happen. Remember, with probability, you're always dealing with fractions. You never have a probability of 1.1.
Okay.
Okay, you're always dealing with fractions less than 1. So
Okay.
know that when you multiply 2 fractions less than 1, they get smaller.
Okay.
This becomes 12 over 256. That's a very tiny fraction,
That is.
as you would
Yeah.
expect. In other words, to have to spin and get a red and then on the very next spin get a blue has to be a much smaller probability than just getting a red, right?
Uh-huh.
If
Right.
you were adding, you'd have gotten 7/16.
Uh-huh. Exactly, which is wrong.
Well, it's going the wrong way. You're making
Yeah.
the probability easier rather than harder. And we
Okay.
know that it has to be harder.
Okay.
Now, I was going to say, are you telling me I can't get rid of the stupid box that's blocking my question
No
here?
kidding.
Oops. I need to go back a page. I hold on.
No worries.
Got to go back to the right page.
Okay.
This one. They changed this thing so that they go top to bottom now instead of bottom to top.
Really?
Yeah, no wonder I can't find anything anymore. Yeah, always before when I backed up, my most recent page would be at the bottom.
Right.
And that hasn't been the case since I, reinstalled the new hard drive.
Right.
From
So now it's
now,
fine.
the most recent page is the top page.
Weird.
This is one I wanted to pull up because I need the probabilities of each of these.
Right.
So what's the probability of yellow then red?
So you would do 5/16 times 3/16, and then you would get 15 over 256, which is, I'm not sure,
You
reduce.
know why I can't, you know why I know I can't reduce it? Because if I
Why?
was
Oh,
able
because,
to
yeah.
reduce it, I would have been able to simplify it first.
Right.
In other words, 5 doesn't go into 16, 3 doesn't go into 16.
No.
So there's no way I can simplify this, which
Uh-huh.
means that that's got to be the final answer. I'm not going to be able to simplify that either.
Right. Okay.
Now, one other way you can tell you can't simplify it is it's not divisible by 5,
No.
not divisible by 3, and you know why I know that's not divisible by 3?
Why?
Because the sum of the digits add up to be 13, and for a number to be divisible by 3, the digits have to add up to a number that is divisible by 3.
Uh-huh.
So if the digits added up to 12, I would know that it is divisible by 3.
Right.
Or
Okay.
if they add up to 15, or if they add up to 6,
Uh-huh.
it means it's divisible by 3. And
Okay.
sometimes it's pretty useful to know whether something is divisible by 3 or not.
Definitely. Okay.
16. Blue, then yellow, then green.
Yeah. So it would be 4/16, which is 1/4, times 5/16 times 4/16, which is 1/4. And then that would be equal to 5 over 256.
Okay.
Cool.
18.
Okay. Oh man, I'm not like they expect you to know like how many hearts and diamonds and
They do.
kings and
Part of,
queens. I
part
don't. I
of
mean, like I know
probability,
the cards.
part of
That's
probability is knowing cards.
yeah, which I
Knowing
didn't
what
know
a
that one.
52 card deck looks like.
Yeah.
52 card deck has 4 suits, and each
Okay.
suit has 13 cards in it.
Okay.
You got ace through 10 is 10 cards, and then you have jack, queen, and king, which is 3 paints. So
Okay.
that's how you get 13 cards per suit.
Gotcha.
That's all you really need to know, is that
Right.
the deck has 4 suits, each suit has 13 cards.
Okay.
Now, this is one with replacement, one without.
Yeah.
So what's the odds of getting a heart?
So it's 13 hearts?
4 suits. Remember it that way either.
Okay.
There are 13 hearts out of 52, but there's 4 suits. So 1 out of 4.
One out. Okay.
Same as 13 out of 52.
Right.
Diamond, same thing. You know
Cool.
what? It is better to write it like this. And I'll explain why in a minute.
Okay.
So with replacement, what are the odds of getting a heart and then a diamond?
So to get a heart, okay, yeah, so it'd be 1/16.
Correct.
Because you do, yeah,
Yep.
1/4
Yep.
times
It's
1/4.
this times that.
Yeah.
Without replacement,
Yeah.
the odds of getting a heart.
Um, Without replacement. So that would be,
Yes, without replacement, the odds of getting a heart with the first pick is still the same, right?
right.
Okay.
Yeah.
But now, what's the odds of getting a diamond?
Now that would be 1/3.
No, it's 13 over
13 over
51.
51, which can't be reduced.
Because there's one, no, it can't be reduced.
No.
But you don't need to reduce it because I'm going to be multiplying.
Right.
So it's 13 over 204.
Okay.
Um, you see why? In other words, by not replacing the card, I'm not dealing with a 52 card deck anymore.
Right.
I pulled out a heart. So
Uh-huh.
I now only have 51 cards. So it's
Okay.
13 over 51, the odds of getting a diamond.
Cool.
That's how you do these without replacement.
Okay.
Okay, so let's do 20.
Sure.
With replacement, in other words, 20A, and then without replacement. Let's just do this and then I'll let you go. So
Sure.
what's the odds of getting a deuce?
Oh man.
How many deuces are in a deck?
4.
Okay,
Uh,
4
yeah, that's
over
right.
52
Uh-huh.
is 1 over 13
Yep.
times a face card.
Uh-huh.
How many
Which,
kings are there?
um, 4?
Same with queens, same with jacks. So
Okay, cool.
there's
So, 12 over 52.
12 face cards, 12 out of 52.
Uh-huh.
So multiply those two together. This time
Yeah,
I can reduce this first.
you can.
In other words,
Yeah.
I can divide top and bottom by 4.
Yep.
So it's 3/13. So it's 3 over 169.
Okay.
And that's not divisible by 3 because the digits add up to be 16.
Right.
Okay? Now, without replacement, doesn't change the odds of getting the deuce, but now I've got a deuce out of the deck. I still
Uh-huh.
have 12 paints.
Right.
Face cards are called paints.
Gotcha.
Only there's not 52 anymore, there's 51.
Okay.
So now, see, I can still divide that by 3, and I can divide that by 3. So it's 4 over 13 times 17.
Okay.
That's without replacement.
Cool.
Uh,
Alright.
Whenever it's without replacement, you're always going to have one less card in there.
Yeah.
All right, Dylan, I'll let
Alright.
you go. I like probability. This is fun.
Me too. These are cool problems. They're not
Yeah,
bad.
they are. No, and they're actually very practical.
They are.
It's you do much of anything in life and you run into probability.
Right.
Whether you're playing poker or card games or anything else, it's hard to escape probability.
Yeah, for sure.
All right. It's like, what are the odds of you getting a hit when you go to the plate? They're
Right.
probably, in your case, like 50-50, huh?
Yeah.
If your batting average was 500, then they'd be 50-50. Let's say
Exactly.
you had 2 consecutive batters batting. What's the
Uh-huh.
odds of both of you getting a hit? Well, it's
1 out of
one half.
25.
No, it's 1/2 times 1/2 or 1/4.
Oh, okay, with 25%, yeah.
25%, not 1 out of 25, but
Did I say that? Oh, yeah, yeah,
it's 1/2 times 1/2. But
right.
you'd have to have awfully good batters.
Oh, yeah, for
So it
sure.
shows you how the odds go down when both people have to get hits. Odds of getting
Exact.
3 hits in a row with 3 500 hitters would be 1/8.
Uh-huh. Which is 16%, right?
Yeah,
Something like
12,
that, yeah.
12%.
Or
Yeah.
12%, okay.
12.5, yeah. All right, Dylan, I will talk to you next Monday night.
Sounds good. Thanks for scouting.